Indirect measurement. Haley is estimating the height of the Superman roller coaster in Mitchville, Maryland. She is 5 foot 3 inches tall and her shadow is 3 feet long. If the length of the shadow of the roller coaster is 40 feet, how tall is the roller coaster? Well, first here, this is what's going on. You've got this big crazy roller coaster. I don't even know what it looks like, right? You can simplify it down and assume that when it's casting a shadow, it's the shadow is being cast from the highest point. So ignore all the crazy stuff that's happening in it. You only care about the highest point. And guess what? That makes you a triangle right there. So here's my triangle for the roller coaster. Now, Haley, she is obviously a some height, and the top of her head is going to be casting her shadow. And guess what? Because the sun is so far away, these two lines from the top of the highest point to the end of the shadow are parallel to each other, and you're assuming that that everything is perpendicular. Guess what? You've got yourself two similar triangles. And I don't even care what the angles are. The angles don't even matter. But because they're similar, I can now set up a ratio. Oh, sorry, I can now set up a proportion. Now I'm going to take a look here. She is 5 foot 3 inches tall. So 5.25 feet. How did I know it's 0.25? Well, there are 12 inches in a foot. She has 3 of them. That reduces down to 1/4, which is 0.25. So she's 5.25 feet tall. And her shadow is 3 feet long. And the shadow of the roller coaster is 40 feet. So guess what? If we have the height to the shadow in our ratio, that tells me 5.25 feet to 3 feet is equal to unknown number of feet for the height and 40 feet. Now it is important that you put it in decimal form here for the 5 foot 3 inches. Otherwise, if you put 5.3, you can see the number is going to be slightly off. But pretty easy to solve this proportion now. Multiply both sides by 40. 40 times 5.25 is going to be 110, I think. 40 times 5.25. Oh, 210. 210 divided by 3. Oh, wait a second. I know 21 divided by 3 is 7, so 210 divided by 3 has got to be 70. So the roller coaster is 70 feet tall. Now, you can use this in real life. It's important that you do it on flat ground, or at least consistent ground. Like if you're if you're doing it with a big tall tree, if you're both on the same hill, then that's okay. But works easiest on flat ground, obviously, because then it's easier to pace out the distance. But you can estimate the height of a tree just by looking at your shadow and the tree's shadow at the same time, and being able to measure, knowing how tall you are, knowing how long your shadow is, and knowing how long the shadow of the tree is. You can calculate how tall that tree is. If there's a shadow. Like this works really good with oak trees because there's usually not a lot of other trees around, and you can see the shadow. If you're in a big like redwood forest, it's kind of hard to see the end of the shadow of the redwood because it's so dang big, the shadow is so dang long, you're never going to find the end of it. But it's something you can actually do to approximate heights of buildings, flagpoles, anything really that can cast a nice clean shadow that you can pace out.